find the zeros of this function. So let's go ahead and factor that. Two numbers that multiply to 3 but add up to 2. That would be -3 and 1. So let's go ahead and set up these two quantities, quantity x plus 1 and the quantity x minus 3. Still, it's set equal to 0. Now let's set each of these terms equal to 0 and solve. So it means our zeros of the function where this graph is going to cross the x-axis is at -1 and 3. So let's go ahead and plot those on the x-axis. So the way this function was given to us, it was given to us in standard form. And remember, if you recall, standard form is ax squared plus bx plus c. Now, c is the y-intercept. So that means that 3, or -3, is our y-intercept. So let's go ahead and plot that point. Let's plot the point at 0, -3. That's where our y-intercept is going to be. The y-intercept is on the left of that axis of symmetry. Now, what about it on the right of that axis of symmetry? So what we can do is take that 0, -3, and we notice that that 0, -3 is 1 unit on the left of the that axis of symmetry. So we can put a point on the right of the axis of symmetry. How do we find the axis of symmetry again? Is we're going to take our P and our Q, add them up, and divide by 2. So -1 plus 3 divided by 2. That gives us our axis of symmetry. So here it is, -1 plus 3 over 2. That's equal to 1. So that means that our axis of symmetry is at 1. Now that we have the axis of symmetry, what we can do is find the vertex by substituting x equals 1 into our function. So we'll let x equals 1, do a little substitution, and then what we get is -4. So our vertex is when x is equal to 1, y is equal to -4, is at 1, -4. So then we go ahead and we plot that point. Now we have 5 points. 5 points I think is good. Now all we have to do is draw a smooth curve right through all those 5 points, and then we can take a look at our parabola.